Hello and welcome to another tutorial session on my YouTube channel. Today we are going to be looking at Norwest Mock March 2020 Further Mathematics question 9 and question 8 and question 10. Now the first question, as you can see on your monitor, it says that find the general solution of the linear Diophantine equation 14x plus 25y equals to 120. Hence, we should find what the positive solutions of that equation. And question 10 says that given that x is equals to x plus iy, where xy are elements of real numbers, describe the locus of z if the magnitude of z plus 1 plus minus 2i is equals to 3. Also, we should find what the least value of what you are seeing there. Now, this is my WhatsApp number. If you are new to my channel, you can always get to me on WhatsApp using this number. And please don't forget to subscribe. It's very important for me. It does not take anything. If you are creating this content for you, you should be able to support us by just subscribing and sharing the video. Let the video go viral. So let's dive into the solution without wasting much of your time. So this is what we have. For the first part of the question, we are going to have let's recall what a linear Diophantine equation is and how the solution look like. We know that any equation of the form ax plus b equals to some c, where ab are integers and ab is different from 0, none of them is equal to 0. This equation is called a linear Diophantine equation and it will admit an integer solution. Very important to note, an integer solution if the greatest common divisor of the a and b divides c. That is actually means that the greatest common divisor between a and b is also a divisor of c. That's what it actually means. And the solution will be of the form. The solution, as you can see, will be of that form. X equals to what? X0 plus b over z. This z here denotes the GCD of a and b, and y equals to y0 minus a over t times some t, and t here is an integer. Now this x0 is called, this x0 y0 is a particular solution to this equation, which we are going to obtain using Euclidean algorithm as follows. Now we have the equation like this. So clearly we can see that a is equals to what? 14, and b is equals to what? 25. So we're going to let a equals to 14 and b equals to 25. Now from there, now we're going to apply division algorithm to get z, that's the GCD of a and b. So to do that, we start with the bigger number and divide by the smaller one. So we are going to take 25 divided by 14. It will go 1 time remainder 11. And now the next thing, now we take a next quotient and divide by what? The old remainder. The next quotient divided by the new remainder. So we have 14 divided by 11. It will go 1 time remainder 3. Going forward, you divide 11 by 3, it will go 11 divided by 3, it will go 3 times remainder 2. So at every stage of division, you apply division algorithm. Now after having that in place, I will now continue like that. 3 now divide by 2, that will give me, it will go 1 time remainder 1. So remember, when you divide a divided by b, the dividend can be written as a quotient times the divisor plus the remainder. That's what I've been we are applying here division algorithm in the Euclidean algorithm. Next, when we divide 2 by 1, it goes 2 times remainder 0. Once we have a 0, we stop the division. Once we have a 0, the greatest common divisor, the greatest common divisor of the integers a and b is the last non-zero remainder in the process. These are the remainders. As you can see, the last non-zero is 1, because we have a 0 after 1. The last non-zero is 1, so the GCD of these integers a and b is 1. And we can see clearly that 1 is a factor of every number. 1 is a divisor of every number. So this equation admits integer solution according to this theorem. Now let's go ahead now to get the particular solution x0 and y0. Now from here we are going to write this greatest common divisor of a and b in terms of what? A and b actually. So we begin with 1. Working backward, we'll be having 1 to be equal to what? 1 will be equal to 3 minus 2. That's, we make 1 the subject here. Next, we now make 2 the subject here and replace in this place. So we are now replacing the remainders backward. So 3 is equal to what? 2 is equal to 11 minus 3 into 3. Please, I beg you, don't simplify. Make sure don't simplify too much here. Group what is common, as you can see. So when we have it at this stage now, we have 3 minus 11 into 3 minus 3, because 2 is what? 11 minus 3 into 3. So when you open up and simplify a bit, you'll be having what? 3 minus negative times negative, you give positive. So we'll be having like 1 3 plus what? 3 threes. So that will give us 4 threes. We have 4 threes minus 11. The next thing now, we are going to replace now 3. 3 now is equal to what? 14 minus 11, right? So you just make it a subject from the equation. Make sure you walk backward until the last equation. So when I do that, I'll just replace 3 by 14 minus 11, and then simplifying a bit, you have 4 into 14 minus 4 times this one. Please don't simplify, put it in parentheses. That will be negative 4 into 11 minus 11. So that will be negative 5 into 11. Now at the end of the day, we have what? 4 into 14 minus 5 into 11. At the end of the day now, we replace 11 by what? 25 minus 14. That will give us what we have there. And when you simplify again, you will have, that's the GCD, which is 1 actually, is equals to what? This time this is 9 into 14, right? Because here will be positive, minus 5 into 25. So we see that we have expressed the greatest common divisor of 14 and 25 in terms of 14 and 25. So after having this now, the next thing, remember we are solving the equation 14x plus 25y equals to 120. So I'll multiply all through by 120, so that because if I multiply it, I'll have 120 here. And please do the multiplication only at the coefficients. Don't touch the numbers 14 and 25. Very important to know that. So I have 120 equals to what? When you multiply 14 by 9, you get 1000 sorry, when you multiply 120 by 9, you get 1080 times what? 14 minus what? 5 times 120 gives us 600 and then bracket 25. After doing this, make sure that when you do this arithmetic here, it should give you exactly 120, because you might make some errors along the way. It's always good to come and verify that at every stage of this writings here. Make sure that at every stage you have one. After simplifying, you should have one. Now that we have everything standard, we can see that x0 is what we have for x, is a coefficient of a, and a is 14. So our x0, that's a particular solution. X0 equals to what? 1080. So x0 equals 1080, and y0 is a coefficient of 25, as you can see in the equation that was given to us. So that will be negative 600. And then with this in mind, now we can now write down the general solution using this relation that we have here. Z is 1 and x0 is known, so we just replace there, and my b is what? 25 t's, and y equals to what? Y0, which is negative 600, and then my a is what? 14, so minus 14t, where t is an integer. Now moving forward, we have to look for what? The positive solutions. This is general solution of the equation. Now we have to look for the positive solutions. For the positive solutions, we have a positive solution when x is positive and also y is positive. That's the meaning of a positive solution. So doing that, when we solve this inequality x greater than 0, remember we are solving for t is an integer. So when you take this greater than 0, you will be having t should be greater than negative 43.2. And the other one, when you take this one greater than 0 and solve the inequality, this is a linear inequality. When you solve for t, you have t less than minus 42.9. And then now with that in mind, we can also write it like t is greater than this, as you can see, but less than minus 42.9. Now remember t is an integer. The only integer between negative 43.2 and minus 42.9 is what? Negative 43. So that's the only value of t that satisfies these two inequality, is minus 43. And at the end of the day, we have our positive solution to be what? We just come and replace t in this general solution that we have here, and we have 5 for x. And now for the other one, for y, it will be minus 600 minus 14 times t times negative 43 equals to 2. That's the positive solution here. The only positive solution of this linear Diophantine equation, 14x plus 25y equals to 120, is actually 5,2. So that's the only positive solution. So we are done with this first part. Let's move to the next part of the problem. Other one is a geometry aspect of complex numbers. That's how they behave on an okay, now we have to look for the locus. Describe the locus of z if z plus 1 minus 2i's, that's the modulus of that, is equal to 3. So we know that z has been given to us, so we can just replace z by x plus iy, plus that will be plus 1 minus 2i. You just replace z by x plus iy, and then at the end of the day, we are going to get we group the real parts together. Remember, x is a real number, so x and 1, they are all the real part of this complex number, and then the imaginary part, we can factor out the I to get y minus 2 equals to 3. Now this is the modulus of a complex number, so we take a real part square plus a imaginary part square, all that square root, equals to 3. At the end of the day, we get squaring both sides gives us this equation. This is standard equation of the Cartesian equation of a circle centered at negative 1, 2 and radius 3. I think you can recall that. So So that describes the locus of Z is a circle of radius 3 centered at -1, 2. That was what was required of the first part of the equation, 2 marks. So for the second one, we have to look for what? The least value of this. We are going to begin with this. So we have what we have there. Look at it. Z plus 6 plus 10i. That's what we have. Since we know this result that is equal to 3, I want to use it there. I would like to use it. So I'll replace it z plus 1 minus 2i. And to create some sort of a balance, since I already have I have 1 year and I needed a 6 year, so I have to add a 5, right? So that's just 6. That's we have z plus 6. What about the 10 i's? Minus 2. Since I have introduced negative 2i, I will have to add the 2 i's to the 10i, giving us 12i. So that I have not changed anything. So I've just created this expression that we have here inside here. Now when you go ahead to simplify, here we can factor out a negative to get minus into minus 5 minus 12i. After doing that, now we now apply the triangle inequality. That will be greater than or equals to the first part minus the second part. This is standard inequality, which is very easy to quote. Now the modulus of this has been given to be 3, so we just replace it by 3. And for this one, this is a complex number where you can get a modulus. The modulus of this complex number is 13. That's 5 square, the real part square plus the imaginary part square, or that square root. Is 5 squared is 25. 12 square is 144. When we add the 2, we get 169. Square root of 169 gives us 13. So at the end of the day, we're having 3 minus 13. That's greater than or equals to minus 10. 3 minus 13 minus 10. So from here, we can see that the least value of this expression is equal to what? Negative 10. So we are done with the presentation. I thank you all for watching. Kindly hit the subscribe button, turn on the notification bell. Please, I want you to share this video, share the video so that I can go viral to all the students in Cameroon, so that they can also benefit from what you have benefited from this video. And please, if you have benefited something from this video, don't forget to subscribe. Very important. It's important to me, please. Now, like I said, you can go to the first slide that I presented. My WhatsApp number is there. You can always get to me on WhatsApp. I also organize revision in WhatsApp group, so you can get to me through that number, so that I add you up in that forum, so that you can better interact and let me know what you want in the comment section. Share your likes and dislikes about this video. I guess none of you have a dislike. Bye bye. See you guys in my next tutorial. Stay tuned.